Let me do this quickly. It's going to give us here. Notice it's too little, and I'm not. So I'm guessing we're going to get something less than 2.3 bar. This is f of 1 equals 1, and so on. So this is going to be 1/4 times f of 1, which is going to be 1. F of
Oh, that's your rule for
5/4, so
I remember those for finals.
16. Notice it's this a sub 2 here is the same rectangle as a sub 1. The previous one. You see everything's just shifted over? So if I took all this and shifted it over, you see I'd have the upper rectangular with an extra one on the end and missing one on the other end? So it's the same thing. That's going to be 9/4, 16. Okay, there. That's going to be the next one, which is 29/16, which is 4. And that's going to give me
63/32.
63/32. Which is about what?
1.96875.
1.9.
6875.
So we have too much and too little. Now, a common way that used to be done, and by the way, I could bore you even more and say, okay, now do both of them again, but n equals 8 in this case. Or n equals 10. Or n equals 50. Okay? Now, those of you that were whining about, I don't want to do any programming, you're going to want to program, right? If you can get a program that will automatically generate all these answers automatically, then why not? It's not hard to do. So, too little, too much. So what I want to do in this case is I want to find the average. You all remember how to find the average? Please say yes. Okay, add them up, divide by 2. What do you get?
70. Oh, those.
Can you read the whole thing? Notice this is still too much.
343.
3, 4 here? Yeah. Good enough. 2.34, so that's a little closer to 2.3 bar. Now if we were to do it again when n equals 8, it would be a little bit closer. And if we had n equal 100, it'd be a lot closer. In fact, either of these methods alone, as n increases, it's going to become more and more exact. Okay? Eventually, as n goes to infinity, we all know, we call that the integral. It's called the Riemann sum. Okay? Now, this 1/4, each time, that's your dx. That's your delta x, right? But as, where am I? Up here, as n goes to infinity, delta x is getting smaller and smaller and smaller, right? That's where we get our dx from. That's why it's called an infinitesimal. It's infinitely small. We okay? All right, let's take a break.